So now let's look into the questions that had come. Okay. So here are some of the questions, right? Bharat Pasupaliti asks, does the course in Ycrash cover 21? Yes. Answer is yes. So the online JVM course and the Ycrash tool set do support Java 21 and also the above versions as well. Okay. So the next question is from Royness Moon. Okay. So Royness Moon is asking a good question. From this data, how will I know which is the exact code where this map is created or used? Okay, you are showing me the children. How will I know from where it is being created? Right? So, Royn's Moon, the answer to that question is, see, here is your object in the largest object section. What do you want to do? You want to click on more. And then here, I ask you to go to the list objects, outgoing references. Right? What are the outgoing references? What are the children? And there's another option here called as the incoming reference. So incoming reference tells who is pointing to this object, who is keeping this object alive in memory. So when you click here, so for this example, I'm just picking up this thread. You can see I can drill down. Oh, okay. So this is what it is. These are the guys which is keeping it active in memory. I can drill it down and then I can see. So go for the incoming reference. That's going to tell who is going to keep the objects in memory. Okay. So now the Tobias Freck is asking, can ePiro recompute the hash codes of all the entries in a bucket and point out if the entry of the bucket do not have a matching hash code? Tobias, no, we don't do such things. The heap dump analysis tools, they don't do it. Okay. So Tobias Freck is asking another question. How many threads do the finalization? Just one thread in parallel or serial? Freck, you'll be very surprised, right? This is a natural question that comes because JVM keeps creating a bunch of threads, a bunch of finalized objects. So it should have, we assume to have multiple threads, right? No. Answer is just so one single thread, it's a finalizer thread, and it works in serial manner. So because of these inherent flaws only, they have moved to the cleaner interface. Okay. So now the next question is from Mark Shinbaum. Looks like the finalizer program had an infinite loop where it creating objects before the finalizer was called. Yes, the finalizer program had an infinite loop when creating the objects before the finalizer is called. Yes. So is it a commentary you are making? Because maybe if we can add more comments. So here is the finalize method, right? As here I'm going on a loop, and then now I'm creating this object which has a finalize method, and I'm putting it to sleep. So I'm going on loop, but because of this sleep only, the problem is happening. Let's say, for example, let's look at this. Let me remove this finalize method. I'm removing this finalize method. Now let me run this program. This program can run without any problem. See, it can keep on running without any problem. There's no problem. Just because the finalized thread, finalized method takes very long time to complete, the thread is getting stuck, the queue is building up. Now here I remove the finalized method. So now you can see it just goes on a loop, keeps creating the objects, but objects gets discarded, gets garbage collected from memory. No problem. The application keeps going, can keep going. Okay. Yes. Okay. So now Sachin is asking, need to understand how we were able to traverse the heap dump to reach the right object that was leaking. So Sachin, maybe what I was doing was I was going to the largest object section, clicking on the outgoing references, and then I was drilling down. So what I do, look at this. Look here, there is this main thread. It tells me what are the children of this main thread is. So here I see, okay, there is this hash map, and these are all the other guys. So, but here, if you see, the hash map is the biggest child. So I'm drilling down on this biggest child. So when I drill it down on the biggest child, I'm going to see what are the children. So I keep navigating like that. Okay, based on the size, I drill down and I keep navigating. Okay. So Danish says, Ram, thanks a lot. You're an awesome teacher and attended your training. Okay, thank you, Danish. It's very kind of you. It's an honor, right? Okay. So Ronis Moon is asking, in the third case, I don't get why thread local string is still alive. Can you briefly explain this one more time? Okay. Okay. So Ronis, that's a good point. Thanks for bringing it up. So let me stop this program. Let's go back to the thread local. See, Ronis, if I don't do this, see here I'm doing this thread local dot set. Once this thread completes, right? So now what happening? I'm creating a thread. I'm putting the thread to sleep. So thread is sleeping for a very long period. That means the thread is going to be there in memory. Thread is going to be there in memory, and it's going to have this string also set. This thread local variable to be also set. So here I'm going on a loop. I keep on creating new threads. And every thread I'm putting to sleep. And before putting to sleep, I'm slapping that thread with a very large string. So that means what? A thread is going to be there. It is sleeping, but it'll have that large string in memory. Then what's going to happen? Then memory is going to leak. Memory is leaking and we're going to get out of memory error. But here, if I do the remove, then what I do, I created a thread local. I put it. Before I put the thread to sleep, before I put to sleep, I'm now removing it. So I can keep creating more threads. But I removed my objects. So there's no memory leak is happening. So that's what was going on here. Okay. 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 So, okay, friends. So I think there are no more questions. Then we will wrap up this session. And thank you for all of you to attending this, taking a valuable time to attend. We will connect with you in another interesting webinar. Okay. Thank you, guys. Bye.